Welcome, data engineers and architects. Let's get started on mastering one of the most critical aspects of data pipelines, scheduling automated data quality checks using Apache Airflow. Welcome. Today we are diving into data quality, or DQ, within Apache Airflow. How do you know when you can trust your data or the predictions from your machine learning models? Data confidence starts with data quality checks running continuously. In Airflow, we build workflows called directed acyclic graphs, or DGs. Think of a DG as a data pipeline where each node is a discrete task. By embedding quality checks natively as tasks inside these DGs, we transform Airflow from a simple task scheduler into an active gatekeeper for our data warehouse. These tasks run automatically on a defined schedule, evaluating your data against strict rules to ensure everything is perfectly accurate before any downstream consumer ever sees it. Let's take a look at this high-level flowchart. It illustrates the basic paradigm of an Airflow DQ pipeline. Raw data is ingested by an Airflow task. Next, it hits our critical checkpoint, the data quality task. If the data passes the checks, the pipeline continues, loading the data into our production tables. However, if the data fails, the pipeline immediately halts and alerts the data team. This architecture completely prevents corrupted data from polluting your downstream analytics. So, why should we use Airflow specifically for data quality? First and foremost, it offers in-pipeline checks. This means the checks occur in the exact same environment where the data is being moved. If a check fails, Airflow immediately stops downstream tasks, acting as a firewall for your BI dashboards. Second, Airflow provides immediate, rich alerting capabilities. When an anomaly is detected, Airflow can automatically fire off a notification to Slack or PagerDuty with the exact error. Furthermore, modern Airflow supports open lineage. This is huge for root cause analysis because it visually connects your failing task to the exact underlying dataset that is corrupted, drastically reducing your mean time to resolution. Finally, its extensible nature means it can run these checks across Snowflake, BigQuery, Postgres, or any other data store seamlessly. This mind map style diagram breaks down our core why. At the center is our objective, using Airflow for data quality. Branching out, we see the three main pillars. In-pipeline firewalls protect our BI dashboards from ever seeing bad data. Immediate alerts integrate with Slack to instantly mobilize engineers. And open lineage tracing provides the deep visibility needed for fast root cause analysis when things inevitably go wrong. Now let's talk about how we actually execute these checks. Airflow recently introduced a powerful suite of native operators specifically for this purpose. The first is the SQL column check operator. This operator allows you to easily validate column-level assertions, such as ensuring a column has 0 nulls, or that its maximum value doesn't exceed a specific threshold. Next, we have the SQL table check operator, which zooms out to look at the entire table. You use this to verify overall row counts or perform multi-column comparisons. Finally, for complex business logic, you have the SQL check operator, which executes custom SQL queries that must return a Boolean true or false. By feeding these operators a simple Python dictionary mapping your columns to your desired thresholds, you can validate massive tables with just a few lines of code. Looking at this architecture diagram, you can see how an Airflow DG distributes the workload across the three primary SQL check operators. The DG triggers the column check operator to inspect granular details like nulls and maximums. It triggers the table check operator to validate the macro details like row counts. And it utilizes the standard check operator for custom, complex business logic that doesn't fit a standard template. Together, they form a comprehensive data quality suite. Let's dive deeper into the architectural pattern you should use. A common mistake is running data quality checks directly on live production tables. This is dangerous because if the data is bad, it's already in production. Instead, as senior engineers, we use the staging pipeline architecture. The workflow is simple. First, Airflow ingests the raw data and loads it into an isolated, temporary staging table. Next, our SQL check operators run their validations exclusively against this temp table. If a check fails, the pipeline dies and production remains completely untouched. Only if all checks pass with flying colors does Airflow execute the final task to safely merge or copy that data into the production table. This guarantees zero contamination. This sequence diagram clearly illustrates the staging pattern. Airflow acts as the orchestrator. It extracts data from the source and loads it into a temp table. The critical moment happens next. Airflow runs the SQL check operators against the temp table. We then have a conditional split. If the checks pass, Airflow merges the data into the prod table. If they fail, Airflow immediately halts the DG and alerts the team, ensuring the prod table is never exposed to the corrupted data. However, the staging pattern introduces a new problem. If a data quality check fails, Airflow rightfully halts the DG. But this means the task designed to delete that temporary staging table never runs. Over time, these orphan tables consume massive amounts of costly cloud storage. To solve this, Airflow 2.7 introduced a brilliant feature: setup and teardown tasks. By marking your deletion task with the dot as teardown method, you explicitly tell Airflow that this is a cleanup operation. Airflow's scheduling engine guarantees that teardown tasks will always run, even if the upstream data quality checks fail. This ensures that your temporary tables are ruthlessly cleaned up every single time, keeping your cloud costs aggressively optimized. Look closely at how setup and teardown fundamentally alters the DG graph. We start by creating the temp table and running our checks. Notice the conditional split at the checks. If they pass, we load to production, and then flow into our teardown task to drop the table. But look at the failure path. Even if the pipeline halts, there is a dotted line guaranteeing execution directly to the teardown task. Airflow bypasses the failure state strictly to ensure your cleanup logic executes. When a quality check inevitably fails, silent failures are the enemy. We must alert the team immediately. Airflow handles this elegantly using the onFailure callback parameter, which can be applied to individual tasks or the entire DG. When a failure occurs, Airflow triggers this callback function and injects the runtime context. This context is a goldmine. It contains the exact task ID, the execution date, and the log URL. A best practice is to take this context, format it into a readable message, and pass it directly to a Slack webhook operator. In milliseconds, your data engineering channel receives a Slack ping from Failbot detailing exactly which data quality check failed, complete with a one-click hyperlink directly to the Airflow logs for immediate troubleshooting. This state diagram walks through the lifecycle of a failure. The task moves from running to failed. This state change automatically triggers the onFailure callback. Inside the callback, our custom Python code extracts the runtime context, grabbing the task ID and log URLs. This rich data is handed to the Slack webhook operator, which securely formats and transmits the message to your team's channel, delivering the alert. Let's tie everything together with a highly practical real-time use case. Imagine you are building a pipeline to analyze the financial impact of forest fires. First, our setup tasks create temporary snowflake tables and load raw fire and cost data. Next, we run our data quality checks. Using the SQL column check operator, we assert that the forest fire ID column contains absolutely zero nulls. We also check that the relative humidity column never exceeds 100, because physically, humidity cannot be over 100%. On the cost side, we assert that the affected geographical area is greater than or equal to 0, preventing negative physical areas. If these physics-based and schema-based checks pass, we merge the tables for complex transformations. Finally, our dot is teardown. Tasks seamlessly delete the temporary snowflake tables, keeping our warehouse pristine. This is the complete architecture for our forest fire pipeline. We load the raw temp data and fan out into two parallel task groups for our quality checks. The fire group checks for null IDs and invalid humidity. The cost group checks for negative areas. If either fails, we trigger a Slack alert. If both pass, we transform the combined, validated data. And notice how all paths, both success and failure, ultimately converge on the teardown task to drop those temporary tables. To wrap up, let's cover a few senior-level best practices. First, use task groups. When checking dozens of columns, your DG graph can become incredibly messy. By grouping your SQL check operators by table within a task group, your UI remains clean and easily readable. Second, leverage default args within those task groups. You can pass your database connection IDs and failure callbacks once at the group level, rather than typing them out for every single operator. Lastly, keep your Python files clean. Use Airflow's template search path to store complex SQL validation queries in separate .SQL files. Airflow will automatically find and render them at runtime. Mastering these techniques makes your pipelines bulletproof. I invite all of you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you next time. Our final diagram summarizes your path to data quality mastery in Airflow. By combining task groups for organization, default args for concise coding, and externalized SQL files for readability, you naturally converge on the ultimate goal: bulletproof data pipelines. Thank you for watching.